today we will be discussing first a very quick back to basics on pulse eddy current for the non-initiated folks. We'll go very quickly on what this technology is and what Eddyfi introduced on the market to do pulse eddy current. And then we will move on to the 5 secrets on how to be a pro at pulse eddy current reporting, which are to set the inspection in lift, how to automatically create the models in SurfacePro 3D, how to adjust your model so that it fits the real life asset, how to finalize your report, and finally how to try SurfacePro 3D for free on your own, which we'll discuss at the end of this presentation. Very quickly, pulse eddy current, or PEC, is an electromagnetic technique for corrosion assessment. It uses a magnetic pulse to magnetize the part, and then we are able to listen to the decay of the eddy currents and extract a wall thickness measurement from that over the averaging area of the probe, which is the area that the probe is inspecting. It is used for corrosion under insulation, CUI, corrosion under fireproofing, CUF, and scab corrosion assessment in the field, and it can be used while the asset is still in service. You don't need to remove the insulation or remove the weather jackets. The pulse will go through weather jackets, either aluminum up to 1 millimeter, stainless steel 1.5 millimeters, and galvanized steel about 1 millimeter. And it will go through also the insulation, which can be up to 12 inches of insulation. It will give you a remaining wall thickness C-scan of the inspection area. Pulse eddy current has been out there for quite some time, since the 80s, the first system. Eddyfi introduced LIFT, our pulse eddy current system, which is the one you see on the screen right now, in 2016. It has rapidly become the most popular PEC system on the market. In fact, we have over 200 units working in the field right now. And all pulse eddy current systems provide you with an export on an Excel sheet with your C-scans that can then be used to report through your own templates. Now, before we had SurfacePro a few years ago, I asked one of our clients if he liked reporting PEC data, and his answer is, it went as follows. I like an Excel report. I just have to copy and paste and stitch all of my C-scans in Excel manually, and then paste that into Word, and then I make a report, and then I export that to PDF. You will agree with me that this does not sound very efficient, and this is why we'll be giving you 5 secrets on how to do a very compelling PEC report much more efficiently, but most of all to make better reports, because no matter how many hours you've spent in the field, either it's on a refinery in Texas under the burning sun, or at the end of the rope on the risers of an offshore platform in the North Sea, what you give your client in the end is always your inspection report. This is what communicates them, the integrity of their assets, and that's the most important part of your inspection. And that's why we introduced a new reporting software some time ago, which is called the SurfacePro, that we'll present you today. This tool is called SurfacePro. It allows to create efficiently reports with compelling 3D models that the asset owner can easily relate to his real-life assets. Here you have an example of a piece of ex-service pipe that we made a report from, and as you can see, the 3D model really matches the asset, and it is a desktop software that we can use after doing the analysis in Lift. We'll now move, we'll move to our first secret, which is the creation of the components and the scan zones in Lift. So basically, this is one of the most important part of your workflow. So SurfacePro does a lot on its own, but the great reports, they start in the field when you define your component. For this small vessel, for example, we made sure we defined the diameter, the length, or the height, if you'd like, of the vessel, the wall thickness, the insulation thickness, and the jacket properly in Lift before we started the inspection. This is going to save you a lot of time later down the road. Part 2 of this secret is the scan zone definition. If you're inspecting a whole component in just one scan zone, such as a short section of pipe, it's not really an issue, but if you are inspecting a pressure vessel with multiple scan zones, having the offsets and the scan zone size defined in lift as you are inspecting them in reality will really save you a lot of time down the road and allow SurfacePro to position your data on the asset automatically when you import it. So make sure you take measurements, take your time, and double check. Here in this example, for that small pressure vessel, we defined 8 scan zones. Each one is covering 90 degrees circumferentially and half the height of the vessel. So we defined all of our scan zones and did the inspection as they were defined. And when we imported the data in SurfacePro, it laid out automatically with the correct positioning. So take your time at this step, defining the scan zone. It will be saved down the road. I have a client, for example, who's very efficient at inspecting pressure vessels with the PEC medium array probe. He told me he can do a vessel 15 feet in diameter, 20 feet in height in just about a day, an 8-hour shift. But before he starts scanning, he takes about 1 to 2 hours to take measurements and lay down a plan of how he is going to inspect the asset. And throughout the day, he defines the scan zones as they are going to be inspected with the proper offsets and dimensions. Now, for today, now that you've seen the first secret, we'll move to our second secret, which is how to automatically create or import the data and create the geometries in SurfacePro 3D. We will be making a report for data we acquired on this piece of X-service piping that we have in the office. As you can see, it's seen better days. It has extensive corrosion on it. So we did scans on the upper horizontal pipe, the elbow, and also the lower pipe. We already did the analysis in Lift or Lift Pro. Ideally, you do the analysis of the data in Lift Pro and you generate the Excel report. And SurfacePro comes into play after you generated the report. The Excel reports, you can import them in SurfacePro, which is our second secret that we are going to discuss here in just a second. So I already opened SurfacePro. We have an empty project, so there's no model right now. If we go to the report tab, you'll see that this is just our default template. For the presentation today, we'll use just the default template that comes with the software, but it will be possible for you to make your own template with your own company logo information. You can also change the layout so that it matches what you like and your own template. So the first step of the secret of creating the geometry is to import the scans. So what we'll do is click import scans right here. So I put all of my Excel reports in the same folder for the purpose of this, but typically you will find the reports in your component folder. We'll import first the upper pipe. Just click open. Now my file is selected. I'm creating a new part, but you could also, if you add geometries, add scans to existing parts. I'm not connecting it to any existing part. I want to add a picture. So this is a picture of my rusty pipe that I want to add to the report. I want to display only the wall thickness C-scan in percentage in the report, but you could also add the other CWT or absolute values or the wall C-scan. I also made a reference scan zone in my inspection component because I wanted to try my calibration and make sure that everything was properly set before I started scanning. So I don't want to show this to the asset owner in my report. I'm just going to uncheck it. And I can click import. Now SurfacePro is looking through the Excel file that was generated by LiftPro. So it's going to find the component definition as well as the inspection data and create automatically the 3D geometries. And as you can see, our data was imported properly. We have the wraparound line here on top, so the orientation is correct. But at this stage, my pipe is laying on the ground. It's not at the correct position. And this leads us to our next secret, which is how to adjust your model in SurfacePro 3D. So the first thing I will do to match my pipe here is to adjust the height, just make it above ground level. So we'll select hit. You can go in the project browser. If you're familiar with CAD software, you'll know about this. So you've got assemblies and parts. Now I want to move it around in the environment, so I'll just adjust the height here. I'll put it to 900 millimeters. Now this project is in millimeters, but if you're working in inches, that's all right. You just have to make sure your lift or lift pro is in inches, and when the Excel reports are exported in imperial format, SurfacePro is gonna also import it in inches, and all of these values here are gonna be in inches. Now that we're good with this pipe, it's positioned right, I will import my elbow. Now you have to know that uh, elbows are completely different animals. They come in a variety of, uh, I mean, for a given diameter and schedule, they come in different radiuses and different angles. Here, for this inspection, we had a 45-degree elbow, and I made a few mistakes on purpose so that we get more adjustments to do on the model, and you can, follow us with those changes. So we'll go through them together. So I'm creating a new part, but this time I am attaching it to this pipe. So the elbow is going to be automatically attached to this. I don't want to add a specific picture for the elbow. Again, I'm using only the wall thickness C-scan. And I did two scans. So my first scan, I didn't define the scan axis properly in lift, so I made that mistake. I don't want to show it in the report. I only want to show my rescan, which I selected here. So as you can see, there's a few things wrong with our elbow now. So first, it's a 90-degree instead of a 45. The radius is too large, and it's not going in the right direction. So first, I'll correct the rotation of the elbow relative to this pipe. SurfacePro could not know from the get start what was the orientation of one relative to the other. So all you have to do is select the elbow. You either click on it here, or you can click on it in the project browser. And I'm going to adjust the rotation. This is the only degree of liberty between, or degree of freedom between the elbow and the pipe. So this is the only value I can adjust. But now we still have a 90-degree elbow. We need to correct that. We have a 45. And I didn't knew what was the actual radius of the elbow when I did my scan, so I put it bigger on purpose. But now I can still come back and adjust it. So I made my homework. I looked at the drawing, and I know that this is a 15-inch or 381 millimeter elbow. So I'm just gonna correct the radius. As you see, we still have a little gap here, but I do know that when I did my scan, I did scan the whole thing. So it's just because of the way the samples are made and little gaps and offsets between everything. You can make adjustment to make it just look like better. So I'm going to select the size of my scan, and you can stretch them or compress them and rotate them. You have a lot of freedom. You just have, to try it and experience with it. So I can make it a little bit larger, maybe 400 millimeters. You can do a few adjustments with trial and error. You can fit everything and make it look better. So now I'm satisfied with that elbow. I can add the piece of the lower pipe, the one that is at the 45-degree angle that we had in this picture. So we're going to add this pipe now. Again, I click Import Scan. I select my pipe or the Excel report. Again, I am creating a new part. I'm connecting it to the elbow. I only want the wall thickness C-scan. I don't want my reference scan zone to show. And I click Import. As you can see, our pipe was imported, but the corrosion here doesn't match. And that's simply because we still need to correct the rotation of the pipe. So I'm going to rotate it. I believe yeah, it was 180 degrees rotated, so I adjusted it. Here we have an empty area, and that corresponds to the area we were not able to scan uh, close to that nozzle. So we scanned as close as possible on this side, as close as possible on the other side, and we scanned on each side, but we still have a very small dead zone, which is what we see here. It looks good, right? But we're still missing a few things. There was a flange as well as a nozzle on the actual pipe that you can see here, the nozzle and our flange. And SurfacePro will allow us to uh, add these. You simply have to go to the 3D toolbox. We have a flange. You simply click on it and you can drag it where you want it to appear in the model, and it is going to attach automatically, which is just what I did. I think it looks a little thick, so I'm going to adjust the parameters. Let me just turn off the webcam so you see everything. You can adjust basically everything on this flange. So the OD, the ID, its thickness, bolt diameter, the bolt circle diameter, as well as the bolt counts. I'm just gonna change the thickness so it's more like 1.5 inches and not 2 inches. And now it looks better. I can add now my nozzle. We have something new for SurfacePro 2.3. So we created a new geometry, which is a nozzle with flange, which we'll add just after. But now we'll use a nozzle with no flange, and we also added T's. So you've got a T-junction now. I will just add a simple 1-inch nozzle. And I will be adjusting its position. So I want it to be just straight up and correct the position. And you have a lot of degrees of freedom. You can really position your features wherever you want on the asset. Now we add a little valve on our pipe, which is right here. So just to make things look a little bit better, I'm going to add this new feature, nozzle with flange. I'm going to drag it here. I'm just going to adjust the position a little bit so that it matches what we had on the actual asset. And you see our scan is pretty good. You see this here, this area closer to nominal. This is what we had here on the pipe where there is no corrosion, and the rest all around it is corroded. So I'm pretty satisfied with this model. So while we were working on that, SurfacePro was working in the shadows, building our report from the template and the scans we imported. And that leads us to our final secret, which is finalizing the report. You simply click on the report tab here, and you're going to access the report. So here our report was populated with the scans we added, the pictures and models. We have here the C scans, and now since the last version, these are vectorized, so you can really zoom in, and when you export to a PDF, this will keep vectorized so you can really give a closer look and get into these C scans to see the values. We have the defect tables from the Lift Excel export, which are pre-populated with the actual values from the report as well as your comments. You've got screenshots of the indications that you added. These were created while you were doing the analysis in LiftPro, and we've got our views. Now here we have a few fields which correspond to properties here on the right. If you are familiar with TubePro, our reporting software for tubing inspection, you know a lot about that. So these properties corresponds to field here. For example, the name is going to be the name of the company. It can be the name of my client. So I'll just add Eddyfi here, and it's going to populate here. And SurfacePro 3D allows you to really customize this template. So you can add your own company logo, customize the fields, add some, remove some, change the layout, and save a template that you can reuse later. We will not fill all of these fields, but this is something you can do now or that you can do later when you do a Word export of the report. Something I'd like to do is correct the orientation of these views. So these were generated automatically, but I may want to show them reoriented. So you go here in your project browser on the right, and you simply select the model view. So this is view 1, the first one. Double click on it. It will open this 3D view editor, so you can just change here the size. I want to display this side. This is where the corrosion is the worst. Again, if you're familiar with CAD software, you'll know about this quick cube here. It's a really nice feature. It has preset views, but you can also, you know, rotate the view as you wish. You can pan and zoom and do pretty much anything. I'm okay like that. You click OK, and then the view is going to be regenerated. Just takes a few seconds. And now we have our corrected view here. Now this one is a little bit out of focus, so I'm going to double click on it. This is our upper pipe. I'll be good like that. If you wanted to add comments to your report, it would be possible to do it here. So I'm just going to say severe corrosion. And say we did duty validations and we had for 25% wall thickness. So you can add comments into your report. And now this is my elbow view. I'm going to show you how you can add a few things to your model. So when you are in the 3D view editor, on the bottom left, there's all of the items you can add or remove from the view. So say I want to add the upper pipe, and it scans. I can do it here. I can also add the lower pipe. I can add the flange if I like, the nozzles. So you can really get into the details and really pick and choose, you know, what you want to display. For that view, simply click apply and OK. And then again, takes a few seconds and the view is regenerated. And now our elbow has been done. So this is the scan for our elbow. And we could just go here. This is our lower pipe. Adjust this view to finalize the report. Just like that. I'm going to add the nozzle and the valve. And now I'm happy with my report. You've got multiple options for the export of this report at this stage. You can either export it to a Word format if you're more familiar with Word to finalize the report and add pictures, which is also something you can do here. So you simply, if you want to export it, click Export. You've got a variety of formats, so you can export it to a Word document, a PDF, EPUB. So there's quite a few options. I can do just a Word format. I'm going to call it my Rusty Pipe report and save it. And now I can come here and open what I just exported. And this is my report in a Word format that I can complete and edit as you wish in Word. You could also have exported to a PDF. And this is the report we just made, which was exported to PDF. So we went fairly quickly over this report. This is a relatively simple assembly. SurfacePro is good for average size pressure vessels or inspections report that are about up to 100 pages. If you are doing larger inspection projects, I suggest that you split your reporting into multiple reports so that everything can fit on 8 by 11 sheets and make it look good. So that was our fourth secret, which was finalizing the Excel report. Here I just have an example where I added a few more pictures to my report in Word just to make it more compelling. Which leads us to our last and final secret, which is trying SurfacePro for free. So we have a 15-day trial of SurfacePro that you can try. It's the complete software. The only difference is that there is a trial watermark on the 3D views, but you can play with the features for yourself. And SurfacePro is going to allow you to make great reports with compelling 3D views to save a lot of time making your reports for pulse eddy cringe inspection. So you don't have to copy and paste Excel cells anymore. You never have to do that again, which can be very time consuming. If you've done it, you know what I'm talking about. There is a link in the video description on YouTube that allows you to request a trial for SurfacePro 3D. You simply have to put in your email, your name, and we will shortly send you an email with a download link for SurfacePro 3D. So I challenge you to either keep doing your reports on your own, try to make such compelling reports with 3D views like that, or you can try SurfacePro 3D. And after 15 days, if you cannot get enough, you can contact us at Eddyfi or your sales representative to get a quote for a full license of SurfacePro 3D.